Welcome to the Aculon NanoProof Series webinar. Today we're going to be talking about PCB water protection technology. I'll start with giving an overview of the technology, then talking a little bit about why PCB waterproofing is important, talk about some devices and then the coating equipment, and then we'll wrap up with a summary. We'll leave plenty of time for questions, so please use the question box in the control panels you can see to submit your questions during the presentation, and then we will basically try to address as many as possible after that. My name is Edward Hughes. I'm the CEO of Aculon, and we're the producers of the NanoProof Series waterproof technology. I'm joined here today with Eric Hansen, who is the Vice President of Technology and the inventor of the NanoProof Series, and Mario Gattuso, who is the Senior Product and Business Development Manager for our electronics business. Aculon is a leading provider of surface modification technologies. All our business is around creating surface solutions so that we can treat a variety of products, including some large markets we compete in, oil and gas, consumer products, as well as electronics. And today we have over 25 different commercial programs going. We surround ourselves with a strong intellectual property base with 28 granted patents and 15 more in process. And we focus on providing repellency technology that modifies surfaces in seconds with little or no capital. Some of you in the electronics business will know about our NanoClear award-winning stencil technology that we launched in 2013, and it's been the #1 global stencil nano coating since that time frame. The purpose of this NanoClear product is to modify the contact surfaces to make them flux repellent, and it does it in a white-based technology and does it in minutes. It's been a very successful product and increased yields and output on a lot of SMT lines, improved print quality, and reduced print variation, as well as lower cost. We've also been the recipient of numerous awards for that technology. But today we're here to talk about the NanoProof series for PCB water protection that we launched back in May of 2015. Let me give you a quick overview of that. The NanoProof series is designed to make printed circuit boards water repellent and to do it in minutes. Clearly the benefits of having water repellent circuit boards are that it will reduce product failure, improve product life, reduce the number of returns. This technology will also allow you to increase yields as it enables rework during the process and will reduce overall cost. It's a proprietary technology that we developed after years of working in the repellency business, and we believe, based on some of the testing that we've seen and some testing I'll share with you today, that it surpasses competitive coatings in terms of performance and ease of use. The application equipment is easily affordable and is readily available. So at Aculon, our business is really developing and supplying easy-to-apply surface modification treatments. We do that with a variety of technologies that can be hydrophobic, hydrophilic, oleophobic, and even oleophilic. We're headquartered in San Diego, but we have distribution partners in Asia and in Europe. Our technology revolves around a variety of portfolio of technologies. Initially we started with the self-assembled monolayers and organometallic technology. We added to that polymeric organometallics, transitional metal complexes, and other surface modification technologies. The benefit of all that is it gives us a variety of technologies to focus on our surface modification business. Our expertise, taking our surface modification platform, can be used in a variety of industries, including our specialty product business, which is for optical, sapphire, and watches, for specialty particles. In our electronics, we have the PCB protection technology. We have our stencil products. We have our oil and gas anti-fouling, proppant, and rock formation treatment business. And then we have a new area we're focusing on in medical diagnostics. But today let's talk about PCB protection. and we'll talk a bit more about our PCB NanoProof series here. So why do you need waterproofing? In real life, obviously, PCBs are often damaged by water, whether it's a handheld device that can be dropped into a swimming pool or even a toilet, or whether it's a automotive application or unit that is exposed to the outdoor environment, including rain or humidity, or whether it's household appliances that are exposed to water during operations such as refrigerators and dishwashers, or whether it's equipment used in industrial and medical applications that often get exposed to wet working conditions. These devices can often be damaged with that exposure to water. Since launching our NanoProof series of products, we've enjoyed a fast start to this and have been qualified in a variety of applications, including mobile device, wearable electronics, exterior smart home electronics, outdoor fitness electronics, and we are working on a variety of other applications and tests, including automotive appliances and lighting. So the benefits include, with this series of products, instead of just having one product designed to try to fit all our requirements, we developed a series of products so that you can go from a limited amount of exposure to water, such as humidity or splashing, to full water immersion. The benefits of that, obviously, is if we can protect the PCBs, we can reduce the product returns. And then, as you'll learn in this webinar, that our treatments are such that you can basically allow you to rework after the coating has been applied, as opposed to some conformal coatings which obviously set. We also believe that in most cases there is no masking required. We've had some customers using minimal amount of masking, and the coatings are safe, they're non-toxic, and can be used in the factory environment. So our solutions are, using this proprietary technology, will give you a variety of formulations which are economical in cost, and they can be applied using a spray, dip, or dispense methodology, and require a limited amount of equipment, and in all cases we provide a UV tracer. Let me turn to my colleague Eric Hansen to talk a bit about some of the benefits and the features of that of the NanoProof series.
Okay, thanks, Edward. So we, like Edward said, we have a wide variety of different surface treatments, and this is done partly because there's such a wide variety of electronic devices and configurations that customers will also often have a pretty wide variety of things that they want the coating to do. So, but in all cases, these materials are meant to be hydrophobic or water repelling, and they have the ability to protect a wide variety of surfaces on PCBs, because you've not only got polymers, you've got metals, a wide variety of different metals and polymers, so it needs to be able to stick to those materials and create the hydrophobicity, which it does. The materials, they're all really easy to use, which is great. They're easy to rework after coating if there's a mistake. They have good temperature stability, as well as good dielectric properties. Of course, they would have to. And they tend to be thin and liquid at room temperature. There's no curing reactions or anything like that. So they're quite easy to use. They're really just spray and dry kind of thing, and they'll create hydrophobicity on pretty much every surface we try.
So let's talk a little bit about the different products we have in this series.
Okay. So we have currently about 4 different products. Some of these also have some other formulations which are slight tweaks on solvent. For some customers, they have very specific requirements on drying time or something like that, and we can help people out if that's what they need by doing solvent swaps. But these are the 4 major ones that we currently are selling. NanoProof 1.0, 3.5, and 4.0 are similar base chemistries. This is our transition metal complexate chemistry that we use. And the general thought here is basically it's like a soft coating even after drying, and this allows push-through conductivity. But the functional groups on this polymer are hydrophobic, and it uses organometallic agent to bind it to substrates. NanoProof 1.0 is probably the outlier in terms of thickness. That goes down in very thin coatings, and it's really meant for customers who just want hydrophobicity, just to prevent water ingress through small ports, or if water does get on the board, it slides off, that kind of thing. 3.5 and 4.0 are beefed up in terms of barrier properties, ion migration, that kind of thing. So they tend to be a good bit thicker, 10 to 15 microns or so. But all three of them allow for push-through conductivity even after drying, which is nice for some customers. NanoProof 5.1 is a bit different chemistry. This one is based upon fluoropolymer chemistry. So like the other three, it's a simple spray and cast kind of film. It just dries in place. However, this one ends up giving the best barrier properties, forms a physical barrier to shorting out of the contacts or ion migration. This one is still actually push through. You can still do push through conductivity, but you have to do it while the film's still wet. But all three of them, or sorry, all four of them are easy to use. I guess the last point there is for 5.1. After it's dry, the handling you can be a little bit rougher with it compared to the other three.
And I know we use the phrase push through conductivity, but maybe you can elaborate. This is when after you sprayed it, you can now connect it.
Yeah, so if you had some kind of like push pin connector or something like that, where you're just making physical contact between two gold pads, you can do that easily with all four of them. The only proviso is at 5.1. After it's dry, you'd need to use some solvent or something to soften it up.
And how long does it take from 5.1 to dry?
It depends on if it's underneath the chip or something on a flat substrate. It might take about 10 minutes or so.
Okay. So you had time.
You have some time, yeah.
Okay, and then the application methodologies, you got some choices.
Yeah, we heavily recommend spraying. That seems to be applicable to all four. Very easy to work with. I mean, we just have a manual spray here from PVA that works just fine. The process is very fast. It's almost like using spray paint. It's just 5 seconds. 5 seconds. The drying time is pretty quick. It can be sped up obviously with warm air or airflow over the part. That's necessary. If someone wants a really thick coating, they can just keep applying. They can just apply and dry, that kind of thing. If there's some very sensitive part, a very high power part. We can also do dispensing. That's actually a pretty good way to put it down as well. Especially if cost is a concern, that's kind of the most economical way to put these coatings down. Dipping, some people have done dipping. We don't really recommend it, mainly because dipping tends to put down coatings that are pretty thin. So if you want to put down a thicker barrier, dispensing and spraying usually works better. But some people do dipping and it works fine for them.
Okay. So I know a question that we normally get, and certainly when we're at Productronica in November, people kept asking us how does it compare to conformal coating. So we kind of came up with the top 10 advantages for this technology against conformal coating. So first of all, obviously rework is possible, and it sounds like people are used to using conformal coatings don't have that opportunity, because when the conformal coating is set, basically it's very hard to scrape off or remove from the board. In this case, as Eric Hansen explained, you can basically wipe this off and you can remove this coating very easily, so if you need to rework it. Secondly, no masking is required, so even you can even coat batteries, so that is a nice advantage. The third is the capital equipment, and I'll give you some demonstrations of the types of capital equipment that can go from a handheld spray all the way up to a fully automated piece of equipment, but no chambers and no curing is required, so that helps out, which also makes it, you can do inline production, so you don't have to put these in a batch type production process such as an oven or into a chamber. Fast cycle time, as we discussed, it's in minutes as opposed to 1 to 5 hours of curing and drying and all those type of things. So that'll hopefully improve the productivity of the operation. The push-through connectivity is great, so it allows you to basically spray the whole board without having to mask certain connections, and then you can basically push the pins through to connect that board to the rest of the device or the unit. We are flexible in terms of the application methodology, so whether it's spray, dispense, or dip, as we've seen with many customers, spray seems to be the best way to do that, not only from a performance standpoint also, but from an efficiency standpoint. You can spray the whole board. It's safe, it's non-toxic, and for those of you who struggle with conformal coatings, it is not a conformal coating. So that is great. And maybe, Eric, you want to take this one, talk a little bit how this compares to Parylene. I know some people in Europe have been trying, experimenting with Parylene coatings over the last 4 or 5 years.
Sure, no problem. So Parylene's been around for a while. It's actually pretty cool technology. It uses a vapor phase reaction of a aromatic compound to make a very thin but very dense coating on substrates to protect them from a wide variety of different things, but mainly it's meant for waterproofing electronic devices. Um, the really biggest difference between Parylene and other solution-based treatments is that Parylene's got to be done in a vacuum, and it's got to be done in batches, and it's pretty slow, and the capital equipment's really expensive. So you're talking about doing really slow cycle times, and you know it's great when it works, but you really don't see a lot of penetration of this type of material except for in things like hearing aids and that kind of stuff, just because you can jam a lot of them into a chamber. Um, the part size obviously is limited because you have to do it in a vacuum chamber, um, and it can treat that. It can't treat batteries. Our types of materials can just be simply sprayed down and dry. It doesn't get really much easier than that. And from what we can tell, or at least from the testing that we've seen, the materials that we put down are just as good. And it's a lot easier to use. And you can use these on large PCBs, small PCBs, things that are high throughput. If you want to run thousands and thousands or even millions of parts, it's not a problem. You just pop them into the little spray booth spray and you're done. You don't have to build some massive vacuum chamber and spend a lot of capital equipment.
Okay, good. I'm sure we'll get some questions on that as well. So again, I remind you, please send in questions as we go through this webinar, because there may be some things that we can address specifically to your needs later on. So let's talk a little bit about some devices and the coating equipment. So this technology has been proven on a series of devices, as I talked about at the start. So whether it's mobile devices or wearable devices or even in-home electronics. So we found that it's compatible with the key components. In the mobile device space, people often use the IPX series to basically determine the level of waterproofing that people want, and I'll go into that in just a second. And so we've seen that 3.5, 4.0, 5.1 can deliver IPX7 or beyond, which is the 30 minutes of water immersion at a meter. So, but I'm going to throw this caveat out there because every device is different. And so while we've proven this on many devices, we're going to say your device is probably different, and clearly you need to test it. And so I'm sure as engineers, that's what you're going to do anyway. But the good news is we think we have some technology here that can deliver some pretty neat performance. And it's been proven that it doesn't impact key components. So whether it's the antenna, the headphone, push buttons, cameras, sealed LCD displays, etc., is fully functional afterwards. The unsealed LCD display is not. So sometimes we get people asking us, can you treat the whole device, the whole mobile unit? And the answer is no, because in many cases treatments are extremely they're very thin, and basically they have a low surface energy so that they can get inside these displays. And so if you have an unsealed LCD display, then there's a good chance the treatment will get inside that display and damage it. So we do not recommend you just put the whole phone or the whole device if there's an LCD display into our treatment. So this is this IPX standards, and you can find these obviously in various places on the web. And they go from obviously having no protection, through to all the way, continual water submersion. So we have customers that have different requirements, and we often find it's very important early on to, as we have a series of products, is to try to understand what the customer wants, because in many cases people will come to us and say, oh, they want full barrier, waterproof protection, etc. And in reality they may be dealing with it's a PCB that's inside of another unit that may get exposed to humidity, or it may get splashed occasionally, etc. And in those cases, we have less expensive treatments that can be used rather than something like a IPX7 or beyond, which requires a greater barrier property. So we ran a series of tests to basically look at what we can provide. And on the right-hand side here, you can see through IPX level 4, which is basically splashing water from any angle, NanoProof 1.0 does a very good job. And NanoProof 1.0 is certainly the least expensive of these treatments. And so we've had customers that come to us and they're asking for the higher end treatments. And we say, you know, based on what your requirements are, maybe NanoProof 1.0 works. If you're looking for, you know, kind of IPX5 and beyond, then you're looking into one of our more barrier-like type property treatments. So the great thing about this series is it allows you to choose which is better. So, and then we ran a series of tests on this IPX level testing, and maybe Eric, you can talk a little bit about the types of testing we did and explain what's going on here.
Sure. This is the IPX test pattern that we used. Basically how this works is you have an interlocking comb pattern, and you apply opposite bias to either sides of the comb. So you provide a lot of chances for electricity to hop across. We've submerged in some water. Essentially what you build is an electrochemical cell. And in an untreated or uncoated board, you rapidly get ion transport, corrosion, and then eventually full conduction through water across the comb, and you short out circuit. So this is meant as a sort of high stress test, and we've run it at various voltages as well as not only water but in salt water, which would be inherently conductive already. In salt water, of course, you're going to get immediate conduction through and immediate shorting out. So we can go ahead and jump to the results.
It take just 1 second to load.
Yeah, it's a pretty big file. Oh, there we go. Okay. So, yep. Okay, so you can see now. You can see uncoated, obviously, in water. There's a pretty quick current spike, and it's dead. And in all cases, with an uncoated piece, what you'll end up getting is immediate shorting out, and you'll also get, in some cases, corrosion, and then it'll actually become insulating from all the copper oxide that's built up. But all of these, when you take them out of the bath, they're completely destroyed. They're just blue or white or black oxide all over the place. However, when we have coated boards, you can see the green line there, 4.0 at 12 volts. Basically, nothing has happened. It's just flat lines. There's no current across the gap, and when you pull them out, the boards look clean. So that's a pretty good proof that you know, these materials are protecting versus being powered up in water.
And there's a lot more available examples in this technical paper that obviously the link is on the screen here, but is available from our website to be downloaded, where you ran it with different volts and different treatments, etc.
Yeah, all kinds of different conditions. That one graph I just showed is just an example of what to expect. It's just basically flat lines of all these treatments.
So for those of you who are interested in reading the technical paper, it's obviously available for download and gives you more details on the testing as well as the different results. But the net of it is, if you look at our series of products, NanoProof 1.0 can basically meet the IPX level 4, and then if you're looking for greater barrier properties, we would be recommending a 3.5, 4.0, or 5.1, and so that is good. We also, as I mentioned earlier on, we have put a UV tracer into all of these products based on customer requests. It can be detected at 295 nanometer UV light, and there are, and I'll show you an example of this in the PVA type equipment or spray equipment. You can have this inline inspection as well, so you can ensure that the product is treated. So performance considerations when thinking about applying NanoProof, obviously, with, the general caveat that every device is different and therefore you need to test it. But we've gone through and we've seen the no impact on most of the key components. We would like to encourage customers to think about the performance requirement they want, and that'll drive the selection of which NanoProof. It impacts, obviously, the greater the barrier, the thicker the treatment is. Also, the thicker the treatment tend to be more expensive, and the handling requirements and manufacturing processes, whether you want to do it via the spray methodology, dispense, or the dip, And the other thing that we always tell customers is the cleaner the board, the better. And so there's very good cleaning solutions available from companies like Kaiser and Zestron, etc., for basically making sure the PCB is clean prior to basically the treatment. Obviously, particularly when you're talking about nanoscale treatments, etc., then making sure that surface is clean is very helpful in terms of ensuring the performance. Let me talk a little bit about the coating equipment that we have here. So as we said, spray, dispense, or dip are options. We've been working pretty extensively with PVA as a preferred equipment partner. There are obviously alternatives, and people are free to choose whoever they want, but PVA has been very helpful with us, and they're a global company. They have operations around the world, including obviously in Europe, and they just opened up a new technical center in the Netherlands. So the standard lead time for equipment is 4 weeks, and if it's a customized piece of equipment, then it's 6 weeks. And let me give you a quick small video of this is the Delta 6 piece of equipment that if you're looking for a relatively automated piece of equipment, this can be done such that it has a feeder that will basically take the PCBs in and take them out. So this can be done on an inline basis. Essentially, this nozzle that's used in this video can be used in a variety of scaled down versions as well. So if you're not looking for such an expensive piece of equipment, and this is relatively affordable as well. The nice thing, it'll take 3 to 5 seconds to do one of the PCBs. So pretty easy process for people to use on that. And the nice thing is they offer a variety of from literally the handheld manual dispensing type of applications to all the way up to the higher volume manufacturing where basically they have automated feed. They also have the UV inspection available as part of the same machine so that you can basically look at the NanoProof coatings under the black light and make sure that you can detect the presence or the absence of a coating if for some reason the programming didn't work. And the same camera can be used for the path for the programming path. So let me kind of start to wrap this up, and we'll get into some questions. So in summary, we are, as you've seen, we're a leading supplier of nanoscale repellency technology. The PCB waterproof technology, the NanoProof series, is designed to provide you options based on your performance requirements, because people sometimes are dealing with humidity and other people are dealing with, they want to have the ability to have full submersion of their printed circuit board. There are samples available from our website. All our technologies are easy to apply. As you've just seen, the equipment is readily available from a variety of suppliers. And we believe relative to some of the costs of whether it's the conformal coatings or paralleling coatings that we can actually help you save money in doing this and give you terrific performance. And we can basically supply this chemistry throughout Europe. So with that, thank you for that, and maybe Mario, if you want to join us, we can start to take some questions. Yes, so Mario's just coming in, and again, if you have any questions, please put them into the question box on the right-hand side, and we will start to take any questions. So. Hey, Mario. Do we have some questions?
Yes, the first question that's come through is, how durable is NanoProof?
Eric, why don't you take that?
Sure, Well, durability is kind of a loaded question, I guess, because it depends on how you define durability. Of course, these aren't meant as abrasion durable coatings or something like that, but for this type of application, when I think of durability, I think of long-term exposure to water or to whatever conditions the circuit board might be exposed to. So temperature, water, humidity, that kind of stuff, and it's stable to all those. It's been, we've had these boards sitting around for quite some time, and we've run them in some cases, we've run them for hours powered up just directly underwater. So they seem to be quite durable at least in our labs, and they're all thermally stable up to pretty high temperatures like 200 degrees C and beyond. I can't imagine many boards would be exposed to conditions much more severe than that. Okay.
Next question that's come through is, can these coatings be applied over a no-clean flux?
Usually not, no. You don't want to have contaminants present underneath the treatment. What will end up happening is that these contaminants are, if you've coated on top of them and exposed them to water, you might actually have the water start to pull these contaminants out. It will act as a way for the coating to delaminate from the substrate. And a lot of these no-clean fluxes will have sort of long-chain fatty acids that are meant to react with the metal oxides that are present on copper to allow it to solder. And that residue remaining is kind of a bit of a problem. So we always recommend people do at least some type of cleaning before applying these types of treatments. And that's a pretty common request from coating manufacturers, to say you can't have it on a dirty substrate.
Next question that's come through is, can you clarify what you mean by push-through conductivity?
Basically, that's for any type of connection that you're going to want to make that isn't done by soldering. So your normal PCB is going to go through a printing process to put solder paste down. Pick in place is going to put components down, but that can't be done for everything. So if you're familiar with these little ribbon connectors or the little polyimide flexible pieces, those have to be pushed in. And if you're running a conformal coating, you'd have to mask that all first. Because if you hit conformal coating in there and then cure it, block those ports. But our treatments, up until 5.0, they can be pushed through at any time later. The coating could be dry. A year later, you can push it through. 5.0 can still be pushed through. You just have to do it while the coating's still wet. Or if it's dry, apply a small amount of solvent first to loosen it and then do push through.
Next question is, can you indicate the capability to selectively coat with 5.1, and is it known what the impedance of the material is when cured?
I don't think we've measured impedance. I don't believe we have. But in terms of coating selected areas, that's where the PVA equipment comes in. They're really able to dial in exactly where you want coated through their software and through the optical recognition that they've put into their machines. So it seems to be really good, at least from what I've seen. They're able to really pick out small parts and put the coating down over like individual capacitors or whatever.
Can any of the NanoProof line coat LEDs with no impact on the light spectrum for transmission?
All these series of coatings are optically clear in terms of you won't get any red shift or blue shift or anything like that. These materials don't absorb visible light. So you should be okay, really. We've done LED strips for people already, as well as LEDs that are part of a board in some cases.
Next question goes back to the selective spraying on the opposite end of the spectrum. Can it be hand sprayed?
Yeah. We have a little hand sprayer here with literally a syringe adapter, and it works great.
Are any of these products silicon-based?
One, 3.5, and is it 4.0? Right? Yeah.
Yeah, that's right.
The first three. Yeah, those have silicon in the polymer. 5.0 is all fluoropolymer, non-silicon containing.
Am I able to change the viscosity after receiving the material?
The only way to change the viscosity really would be through dilution. And that obviously is going to reduce thickness. So if someone needs to reduce viscosity, they could by dilution, but they might need to apply twice. If someone needs to increase viscosity, that would require a formulation change, because then we would have to add some viscosity increasing agents into the actual mix. So we'd probably have to talk to the customer specifically about that if it's a viscosity increase.
So in other words, the viscosity can be changed, but it would likely need to be done at Aculon prior to shipment.
I would think so.
Solution.
Probably do it in communication with the customer, find out exactly what they're looking for.
But these are not viscous.
No, they're really light. Their viscosity is probably less than 1 in all cases.
how is it possible to rework after applying the coating?
So for all of them, if you really want to strip the coating off the contact cleanly, you just use a Q-tip and a small amount of solvent. You just rub it really quick, takes it right off. These materials are still even after curing, even after drying. It's not like a cured film where you would actually have to sand it or scrape it off. These are they're still going to be soluble in the solvent that they were put down in. So you can just take a small amount of solvent, rub the area, and then it's clean. You could also wipe it off, of course, or scrape it off. That's also possible, but for the most part, a little bit of solvent and Q-tip works great.
Next question, what chemicals evaporate out of the products during the drying process?
It's solvent in all four cases. So in the first three, it's a hydrocarbon-based solvent. This is one that's been stripped of aromatics and sulfur-containing compounds. So it's a clean paraffin solvent that will evaporate. And for the 5.1, it's a fluorinated solvent.
And by first three, you mean 1.0, 3.5,
yeah, sorry.
and 4.0.
Yeah. Water vapor transmission rate, yeah. That's it. So we actually have not measured water vapor transmission rate yet. That would be possible, but we need to make freestanding films of them. The trick behind 3.5, 4.0 is that they are still liquid light after they've been deposited. They're sort of soft polymer films. So you'd need to do that on a substrate film that's already present, cast that on top of the film, and then measure the combined water vapor transmission rate. So you want to pick something probably that actually has high water vapor transmission rate. 5.1, we actually could cast a freestanding film and measure the water vapor transmission rate. We just haven't done that yet. But it could be done. Or oxygen transmission rate, whatever you like.
And the question was, is there any data for water vapor transmission rate of the NanoProof series?
I don't have it here, but it can be generated if needed.
Next question is, will we be providing a copy of the presentation? And the answer is yes. Everyone will be receiving, most likely not a hard copy, but a link to our website where they can view the presentation and also download an actual file of the PowerPoint to use at their leisure. Next question is, are the coatings scratch resistant?
No, they're not. None of these are abrasion-resistant treatments.
So they're not
hard coats.
Okay, so they're not meant, aside from 5.1, they're not meant to be handled after application. They're meant to be, the parts are meant to be treated and then be encased in some sort of enclosure.
Yeah.
Next question, is there a minimum surface energy required in dynes to treat a part?
No, not really. These could go down. Let's see, we've deposited them on everything from polyolefins to clean metal because the solvents are all low surface tension solvents, so they're going to wet out well on pretty much everything. I think the only case where you might run into something would be an already like Teflon coated substrate. In that case, only 5.1 is going to wet out, but you really wouldn't need a hydrophobic coating on Teflon. So yeah, I can't think of a substrate surface that these treatments wouldn't wet out just fine. So there's no requirement.
Next question, what is the typical oil contact angle we can expect?
So for 3.0 and for 4.5, you're going to get about 33-ish for oil. So about mid-30s, I think. For 5.1, you're going to get about 72 to 76 or so oil contact angle.
Somebody actually asked, can you explain water contact angle? Maybe people aren't familiar with
how you measure these
things, so I know it's something you do all the time.
But yeah, this is a common technique in the field of surface coatings, but pretty much nowhere else. Basically, how this works is you have I'll explain the simple experiment that we actually will come across quite a bit. Think about having a water droplet coming out of the tip of the syringe, just a single water droplet. A water droplet is slowly lowered onto the substrate, and there's a flashlight behind this setup. So you can see onto a screen cast basically the shadow of a water droplet. When the substrate comes in contact with that, the water droplet will transfer onto the substrate, and in the case of a very clean metal oxide substrate, the water droplet will basically disappear, form a flat film. That would be very hydrophilic. So on the shadow cast, you wouldn't see anything. It just looked like the water droplet disappeared. Unlike a dirty substrate or just a basic piece of plastic with a water contact angle of 80, the water droplet will look like it heated up a little bit. And the contact angle, if you're looking at this, kind of hard to explain from without anything to point to, but if you look at the angle that's formed between the water droplet and the substrate and air, at 90 degrees, it'll basically look like an L shape at that interface. When you start to make it more hydrophilic than just a regular substrate, so you start to go to fluorinated coatings or silicon-based coatings, and you get contact angles of 105, 110, 120, it'll really start to look like it's beaded up, and the contact angle will get quite sharp. And what you'll see is that interior contact line of the interface between the water, the substrate, and the air. You'll get this obtuse angle. So you'll get these 110s, 120s, and that kind of stuff. When you go to the far extreme and have these super hydrophobic coatings where it's 160, 180, it'll look like a freestanding water droplet on the film, like it's not even contacting the substrate. So that will be basically the contact angle will approach being a flat line. But if you search on Wikipedia or something like that, you'll see a much more clear demonstration than what I can do by over the phone.
Yeah, no, it's hard to explain over the phone.
Yeah, it is. It's sort of a weird technique.
So there's a couple of questions on cost, and so if you go to our website, you'll see the pricing for these products on the website, and that's at obviously small scale sample type quantities. If once you get into production and are looking for larger quantities, then we will be able to give you obviously volume-based pricing. But some treatments are from $100 a liter to $600 to $800 a liter. The real question is how much you put down. So if you take a 3x5 printed 3x5 inch printed circuit board, etc., you may be putting down 1 to 2 mils. So it could be anywhere from 10 cents US to 50 to 60 cents depending on it. So it's very efficient in terms of the price per board. So that's pretty good. We got a question asking, what does it mean for a wide range of surfaces?
So this would be metals, metal oxides, glass, FR4, epoxy, the solder mask, copper, tin alloys, of course. PCBs are populated with a vast array of, in terms of surface chemistry, very different substrates. Everything from epoxies and metals and across the board. So, our treatments obviously have to stick to all of that, or have some adhesion, and modify the hydrophilicity of all those surfaces. So that's kind of what we're talking about, is this vast array of different substrates. A lot of coatings are kind of engineered for one type of, one type of surface. Like architectural coatings might be made for aluminum only, and in this case, it's sort of substrate agnostic.
Somebody's asked, is the coating heat resistant? I believe in the presentation we had stable up to 200 degrees C. Yeah. So maybe you just comment on what heat conditions are fine and what are not.
Well, 200 degrees C is kind of our working range that we talk about. Meaning, if you go much above that, you might start to see thermal decomposition of some organic compounds. The 1.0, 3.0, and 4.5 are probably the most heat resistant that we have. Those are probably okay up to about 250, but we would need to do testing to find out. Whereas the fluoropolymers, they can usually handle 200 degrees C with no problem. I don't know so much about 250. You probably want to do sort of extensive a TGA testing or something like that to find out what the actual performance is. Although in contact with the substrate, that does change things.
Okay. I got another question regarding cost, asking how does it compare to other materials? And so cost base, where does the cost savings come from? Is it only capital? So if you are not protecting the board, obviously by protecting the board, you are going to basically reduce the amount of defects and returns that happen in the field. If you are already protecting the board, one of the cost savings by using this technology is it allows you to rework it, and so gives you the ability to improve your yields. Obviously the avoidance of the capital equipment in terms of vacuum chambers and curing ovens, etc., is a savings in the long run. And then this is also pretty efficient in terms of how you apply it. I mean, certainly some of the treatments like NanoProof 1.0 are very inexpensive, and compared to some of the other conformal coatings that are out there, you'll actually save money on the cost of the materials as well. Let's see what else we got here. Is it scratch resistant, or are the coatings scratch resistant?
No, they're not meant to be.
Yes, I mean obviously the purpose of these is designed to protect printed circuit boards, so they're not meant to provide a hard casing as opposed to a water protection for that. And then, can the coating be used for impregnating porous materials? Does it have adhesive characteristics?
Porous materials, yeah. You may need to dilute them to keep the porosity, though. Some of these are meant to go down at, 15 microns or so. And if you have something that's got pores, well, you wouldn't want to see all the pores off. So in that kind of case, we've done things like filter media and stuff like that. But you do want to dilute the chemistry down so that you're not working at such a high concentration range. You just contact us and start the conversation. We can find out how porous the material is and calculate how much material you would need in the solution and so on. And we can work with people if they want to have some porous material treated.
Next question is, do connections or solderable surfaces need to be masked prior to application?
Shouldn't be, because we do have rework capability. I would think that if you've got something where you're going to want to print down solder paste on afterwards, you might want to mask that, or just program the spray equipment so that it doesn't spray over it.
Next question, similar, is can you dip coat unsealed switches?
So like electrical toggles, that kind of thing?
Yes.
Should be fine.
Okay.
That's essentially the same thing as a push-through connection. It's just, repeated a million times.
Next question that's come through is, does the applied thickness impact conductivity?
Conductivity of, not of the actual trace itself. So if you're going from point A to point B across a board from a source to a drain, essentially, it's not going to impact that. It obviously impacts the conductivity across traces, because that's what you're trying to prevent.
What about conductivity of contacts?
So yeah, the 1.0, actually, well, all of them don't impact it until 5.1. When that dries, then yeah, you won't be able to form electrical contact by touch. So if you were to touch two leads to a active trace, the 1.0, 3.0, and 4.5 are going to be fine. 5.1, after it's dried, it's going to prevent that, yeah.
Does the NanoProof series comply with RoHS and REACH regulations? So yes, all the NanoProof line complies with RoHS, with REACH. None of the SVHC chemicals are present in the line, and it's also compliant with RoHS. No heavy metals or any bad actors there.
Do we have any other questions coming in?
Looks like that pretty much wraps up the questions for now.
Okay. Well, thank you for attending. You can see the contact information on this and on your screen. And as Mario indicated, we'll be sending you an email out with a link for downloading the the presentation if that is of interest. The materials are available online for sample quantities. For obviously larger quantities, then please contact Mario directly. We hope to have the opportunity to work with you to test on your boards and hopefully provide you some of the benefits of this technology. So with that, thank you for listening today, and we look to be in contact soon. And we will be shutting down the webinar.